Hey guys, today we're doing Chapter 1, Section 6, which is on choosing a good display. So I've already written all my notes up here just because I didn't want to take the time during the video to do that, but basically I'm just going to go through each type of graph and talk about when would be a good time to use it. So a scatter plot is especially useful in time series data. It's more accurate than a line graph because it doesn't suggest false data. So in a line graph, basically you're given some data points and then you make connections between those data points. Those connections that you make between the data points, are you assuming that that connection is true? Now, I know that the connection is true technically because going from point to point, you do go from here to here, right? But the actual curve of that line that you're making is not necessarily the way that the actual data would go. So basically you're assuming a bunch of data to be true. So scatter plot is a little bit more accurate because you're not assuming anything. It's also only useful with numerical data, so we can't actually use a scatter plot with categorical data. Okay, a circle graph is used to represent the relationship between a whole set and its component parts. So we've already kind of talked about circle graphs. Basically, we're just comparing something to the whole. And then it's also really useful because you can use either numerical data or categorical data. A bar graph shows relative sizes of categories. So again, you can use this with categorical data, which is really nice because you don't always have just numbers. Basically, each one of those sections, each one of those categories at the bottom, or numbers, you can use it with numbers too, is going to be a different height. So basically, you're looking at those different categories and you're able to compare the categories to each other, which is a little bit different than a circle graph where you're comparing the categories to the whole. It's also useful in time series data, so you can use it with time on the bottom and numbers on the side. Okay, box plots, they display the distribution of values of a single numerical variable. So this is good if you are using numbers and you just have one variable, meaning that it's not like an x and y, it's just like an x. Okay? Generally, they're not used with small data sets. So we only use box plots when we have large data sets and we want to find some sort of general pattern among a huge data set. Histograms display the frequency or relative frequency of intervals of values of a single numerical variable. So again, we're just talking about that single numerical variable here, and this is really useful when we have things that are occurring within certain intervals over and over again. So basically we have this large data set. Okay, again, these are only useful with large data sets. We've got this large data set and we want to figure out different categories that we can group things in, and then we can talk about the frequency of each of those categories. Okay. We also have stem plots and dot plots, and those plot the frequency distribution of small data sets. So basically between a stem plot, dot plot, or a histogram, the only difference is that you're using a small data set or a large data set. So if you have a single numerical variable and you want to talk about frequency and it's a small data set, a stem plot or a dot plot is definitely the way to go. Now, a stem plot is more useful with more spread out data, whereas a dot plot is more useful with data that's occurring over and over again. So like if you have 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, that would be really useful with the dot plot, whereas if you had a stem plot, it would be better if you had more like 18, 20, 22, 23, 33, 34, okay? We also have line graphs. So those are especially useful with time series data, just like a scatter plot. It's also good for seeing average rate of change because with a line graph you make those connections between the points. So those connections are like little slopes and you can kind of look at where the highest slope is going to be. Also, they're only used with numerical variables, so you cannot use categorical data for line graphs. Last thing on here is the average rate of change, or the slope. So just remember that your slope formula is y2 minus y1 over x2 minus x1, and that's if you have 2 points. So you can plug that into the slope formula. Also, if you're just looking at a graph, the slope is just the change in y over the change in x. Okay? Last thing on here, an effective display is technically accurate, so you're not fudging the information, and it tells the story that the author wants to display. So, is there just one right answer? No. If I give you a problem, there's a lot of different displays that can be effective. It just depends on what you want to portray. Do you want to compare a data set to the whole? Do you want to compare categories to other categories? Do you want to look at quartiles? It just depends on what you're looking for. So there is really no right answer for a lot of these when you're trying to choose a good display, but there is better answers than others. So basically you just want to be careful about not making false assumptions, and also you want to make sure that you are getting across what you want to get across. All right, that's everything for Section 6.